Greetings, students of chemistry, and welcome to this video section of the basic chemistry series. Welcome. We have been on this series. We've had like 4 videos on it. I would advise that before you start this one, go and view the previous ones we have posted on basic chemistry before you start this one. And before we begin, if you have not subscribed to this channel, please click on that subscribe button there and then tap the bell icon beside it to support the channel and to also be notified anytime we post a video. Okay, let's begin. In this section of our study, I want us to talk about subshells and orbitals. Subshells and orbitals. At the end of the day, we'll now link it to what we call SPDF electronic configuration. So let's go. SPDF electronic configuration. Okay, so now let's talk about first of all the subshells. The subshells in an atom. In the previous video, I told you about the shells in an atom, the KLMN shells, right? So here now, let's look at the subshells in an atom. In an atom, we have 4 subshells. They are the S subshell, the P subshell, the D subshell, and the F subshell. They are 4 in number. And each of these subshells has a certain number of electrons it can carry, the maximum number of electrons it can carry. This S subshell takes a maximum of 2. Then if you want to know the number of electrons this P carries, add 4 to this one. 4 plus 2 is 6. Then for this one, add 4 to this one, you get 10. Add 4 to this one, you get 14. Are you following now? So the S subshell has 2 electrons maximum. The P subshell has 6. The D subshell has 10. Then the F subshell has 14. Are you following? Now let us put them in the orbitals. This S block now has 1 box. Anyway, let me call it box for the purpose of introduction. This box is called an orbital, or you call it a set. So this is 1 orbital, or 1 what? Set. If you want to distribute this, since this one has 2 electrons, you put the 2 electrons inside here, 1 up and 1 down. So the arrows pointing up and down are electrons. So every S block, S subshell, has 1 orbital or 1 set which contains 2 electrons. Every set or orbital contains 2 electrons. Now look at P here. Every P subshell has 3 orbitals. 3 orbitals. And since it has 6 electrons, watch how you use the electrons to fill this orbital. So you have fill the arrows pointing up first. So 1, 2, 3. Then you now start filling down 4, 5, and 6. You see it? So you have to fill the electrons that point upwards first before you fill the ones that point downwards. Now we have the D orbital has 5 boxes. This one is 3 orbitals or sets. This one has 5. Okay, 5 orbitals, 5 sets. We have 5 orbitals or 5 sets. Are we good? Now, let us distribute this 10 here. We have 1, 2, 3, 4, 5. We now have 6, 7, 8, 9, 10. That is the distribution. Are you following? Finally, for F has 7 boxes. 1, 2, 3, 4, 5, 6. So 7 orbitals. Are we good? 7 orbitals. So let's distribute the 14 electrons here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that's how to distribute electrons in the orbitals of a subshell. Now, to summarize this part, you can see that the S subshell has 1 orbital and 2 electrons. The P subshell has 3 orbitals and 6 electrons. The D orbital has what? 5. The D subshell has 5 orbitals and 10 electrons. Then the F orbital has 7 orbitals. This F subshell has 7 orbitals and 14 electrons. So please take note of that. Then, one more thing I want you to pick up here before we go to the next section is that in every orbital, inside every orbital, the electrons are paired. Pair means 2. So you have them 2, 2. So say they are paired. Okay, so take note of that. Now let's go to the next section. So now when I talk about shells, you know what I mean. When I talk about subshells, you know what I mean. When I talk about orbitals, you know what I mean. Okay? Now let's now look at this SPDF electronic configuration. Let us generate the formula for it. Now we're going to draw a box. We'll make a box. Then the box will have 4 columns. 1, 2, 3, 4. Make a box of 4 columns. Then make 1 row here. A row is like this. A column is like this. So put the first orbital here, S2, P6, B10, F14. So do it like that. Okay. Now let's put 5 extra columns, 5 extra rows. So I have 1, 2, 3, 4, 5. Are we together? Now you start from here. Start writing 1s2, 2s2, 3s2, 4s2, 5s2. Do it like this. Okay? Now for P doesn't have 1. P doesn't have 1. We start from 2. So we have 2p6, 3p6, 4p6, 5p6. Are you following me now? Then D doesn't have 1 and 2. We start from 3 here. 3d10, 4d10, 5d10. Okay? Now F doesn't have 1, 2, and 3. F starts from 4. 4F14, 5F14. This is the table. Now we're going to use this table to generate the formula for SPDF electronic configuration. Now watch me do it. You will join this diagonal like this. Join these 3 diagonals like this. Join these ones like this. Join these ones like this. Then join these ones like this. So do well to get it very accurately. Now, the first, you always come from up. Always come from up to down in each diagonal. Now, the first diagonal has 1s2. So copy it out. 1s2. Are we following now? Second diagonal has 2s2. Okay? Third diagonal has, from up here, has 2p6, 3s2. So 2p6, 3s2. Then the fourth diagonal has 3p6, 4s2. So 3p6, 4s2. Then the fifth diagonal has 3d10, 4p6, 5s2. You can keep writing as many as you want, but because we are handling basic chemistry, let's stop at 4s2. If you like, you can even continue down. You can have so many of them, they are long. But let's stop it at 4s2. Now let us begin to arrange them in the orbitals. So this one is 2, 1, 2. Are you following now? This one is 2, 1, 2. Are you following now? This one is, you know, I told you P has 3 orbitals. So this one will be 1, 2, 3, 4, 5, 6. Okay? This one will now be what? 1, 2. This one will be 3 boxes. 1, 2, 3, 4, 5, 6. Okay? Then this final one will now be 1, 2. So this is the formula for SPDF electronic configuration. Now I want us to look at some examples of this electronic configuration for SPDF. Let's look at some examples now. So make a table of this, make a copy of this, and keep it so that you know how to derive that formula. Okay? Then we have all right, let's see examples now, very, very quickly. Now, examples. Let's pick an element from the first 20 elements. Let's pick sulfur, for example. Sulfur. So sulfur. What is the atomic number of sulfur? The serial number is 16, bar. So you put 16. Now, if I want to solve for the SPDF electronic configuration of sulfur, I will use this. Now let's pick it up. So you start adding the powers until you get 16. Now let's go. 2 plus 2 is 4. 4 plus 6 is what? 10. But 10 plus 2 is what? 12. You know we're working on 16 now. And then 12 plus 6 is 18. That means we're not taking the whole of this 6. We will take 4, so that 4 plus that 12 give us 16. So take, when you get to where you're supposed to stop at, take the amount you need, not everything. Let's go again. 2 plus 2 is 4. 4 plus 6 is 10. 10 plus 2 is 12. Remaining 4 to make it 16. So I'll pick 4 from here instead of 6. So I will now have 1s2, 2s2, 2p6, 3s2, 3p4. Can you see it? I took 4 only from the 6. Now let us arrange the electrons in the orbitals. So this one is 1, 2. This one is 1, 2. This one is 1, 2, 3, 4, 5, 6. This one is 1, 2, as usual, right? Now this one is, we have 3 orbitals. So we have 1, 2, 3. But it has 4 actually. It doesn't have 6. So it means it stops at 4. Are you seeing it now? It stops at 4. If it were complete, it would have been 6. It stops at 4. Now, this is the electronic configuration of sulfur. But there's one thing I want us to pick from here. If you look at this now, you notice that all these electrons are paired. Paired means that they are 2, 2. They are double. But after all these things that are, all these electrons that are paired, you can see that this electron is lonely or is alone. or is single. This one is also single. Any electron, when you do the electronic configuration, any electron that is single or left alone in an orbital is said to be unpaired. It's said to be what? Unpaired. So at the end of the day now, it means that sulfur now has two unpaired electrons. Two unpaired electrons. So if they ask you the number of unpaired electrons in an atom, do the SPDF. The electrons that are alone, that are single, are called the unpaired electrons. You now count them and get your answer. Is it clear? Let me show you another one. So let me write this one. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Let's pick another element. Which element do we pick now? Let us pick oxygen. Let's work on oxygen. Oxygen is number what? 8, right? Now let's do 8. 2 plus 2 is what? 4, right? 4 plus 6 is 10. So I'm not picking the whole 6. I'm picking 4 so that I can make it up to 8. So I now have 1s2, 2s2, 2p4. You see why I have 4 here? I didn't pick 6 because I need 8. So I now have this one is 1, 2. Follow the formula here. 1, 2. Then this one is 4, right? 1, 2, 3, 4. How many unpaired electrons? The single ones are just 2 again. So it means oxygen has 2 unpaired electrons. Oxygen has what? 2 unpaired electrons, right? Now let's quickly do another one. Let's do sodium. Sodium is number 11 in the periodic table, right? Number 11. So we have 2 plus 2 is 4. 4 plus 6 is 10. I need 1 left to make it 11. So I come here and pick only 1. So I have 1s2, 2s2, 2p6, 3s1. So you see why I didn't pick 2 now. I picked 1 so that it will be 11. Now let's do this. Then let's draw it. So we have 1, 2, 1, 2, 1, 2, 3, 4, 5, 6. You know that this one has only 1 box, so it's like this. Because it has just 1, so I put only 1. How many unpaired electrons does he have? All these ones are paired. The only one that is single is this one. So it means that sodium has 1 unpaired electron. So now we have 1 unpaired electron. Do you understand it? Okay, so one more example, then we'll round it off. Then you can do the electronic configuration of any element you are given. Which element do we pick now? Let us pick fluorine. Fluorine is number 9. So let's solve it now. So 1s2, 2s2. So since it's 9, I have 4 already here. So I pick 5 here. So it will be 2p5. Then here I'll have 1, 2, 3, 4. That's 1, 2. So this one has 3 boxes. So I have 1, 2, 3, 4, 5. How many electrons are alone? How many? 1. So it means that it has 1 unpaired electron. Is it clear? That's how you know it. Okay? If you want to do something like a neon, what number is neon? Number 10, right? Let's do neon. 2 plus 2 is 4. 4 plus 6 is 10. So this is neon now. 1s2, 2s2, 2p6. If you do like this now, can you see that all the electrons are paired? It means that neon does not have any unpaired electron. Is it clear? Neon does not have any unpaired electron. Okay. Now, that's the topic for this video section. How to do SPDF. So what you have learned here now, let me quickly take summary, is you have learned about the subshells in an atom, the orbitals in an atom, then how to get the SPDF, electronic configuration of an element, and then how to know the number of unpaired electrons. So that is it for this section. If you have learned something from this video and you have not subscribed, click on that subscribe button there, and also you can like the video and comment. Thank you very much. I'll see you in the next section of the series.